Okay, welcome back to part two. And so hopefully you have made your own attempt at graphing g of x, and you have done so without using your TI Inspire. And so I'm going to just take you through this and make sure that you've got the correct procedure and the correct answers. So what I'm going to do is start off once again identifying all the key information, and then plotting and labeling those points and ultimately drawing the sketch of the graph. So straight away, let's pick out some key information. I'll do it in a slightly different order. This minus sign should tell you straight away that our parabola is going to open down, so it's going to have a maximum. And so we can start to find some of our key points. This is a slightly trickier question because it does, the minus in front of the expression does complicate things a little bit in terms of factoring. So what I'm going to do is I'm going to start by taking out the minus sign, which is like taking out a common factor of -1 effectively, and that's going to leave me with x squared minus 4x minus 5, and then essentially we're going to ignore that minus sign and just factor what's inside the parentheses, and that minus, its effect is of course to cause the graph to open down, but it shouldn't affect our factoring, and it shouldn't affect the zeros of the graph. In other words, where it cuts the x-axis. So I'm going to go ahead and leave that -1 there, but I'm going to ignore it in terms of my factoring. Factors to get x squared are, of course, x and x. Once again, a relatively easy factoring sum because 5 is prime, and so the only possibilities for factoring are 5 and 1. Signs are once again different. We need -5 and +1 in this case in order to get our -4x, and so that should allow me to conclude that my x-intercepts are going to be at -1 or at x equals 5. Okay, so I do know that the graph opens down because of the minus and is going to intercept the x-axis at -1 and 5. So I'm going to go ahead and I'm going to plot those points on the graph, -1 and 5. Okay, and we are expecting, of course, for our parabola to open down. So the next thing is for me to find the axis of symmetry as I did in the first example. If I go from -1 to 5, the difference is 6. If I go halfway in between, I should be able to find my axis of symmetry. And so 1, 2, 3 in between, and we should know or should realize that the axis of symmetry passes through x equals 2. And so as I did before, I'm just going to put in a line at x equals 2. So our axis of symmetry is going to be at x equals 2. And I'm going to add in the label over here. X equals 2 is our axis of symmetry, and we do know that the graph opens down. Once again, just to confirm, if that doesn't make a lot of sense to you, or if you're at all confused by that, sorry, let me just eliminate that. If you're at all confused by that, you could always use the formula, and so for the axis of symmetry or for the vertex, we can use the formula x equals -b over 2a. And so in this case, let's go back to our equation. In this case, our b value is 4, our a value is -1, and our c value is 5. And so in this formula, we have minus b over 2 times a. And so that's -4 over -2, which of course simplifies to 2 and confirms our axis of symmetry at x equals 2. We need to find the corresponding y value, and so in order to do that, I'm going to say g of 2, which of course is just another way of saying substitute 2 into the equation in the place of x. And so I have -2 squared plus 4 times 2 plus 5, and so that's going to give me -4 plus 8 plus 5, and I hope I'm not in trouble here with the height of that. Might just about make it. So that gives me 9, and so my vertex or my turning point is at 2, 9, which only just fits onto our graph. So I'm going to have to squeeze in my label over there. That is the point 2, 9. My parabola is of course going to open down. From here, I should be able to identify the y-intercept. That is, of course, at x equals 0, y equals 5. These are the points I found earlier. We have -1, 0, and on the other side we had 5, 0. And the last thing that remains to do is just to find the point which is symmetrical to my y-intercept. I've had to move 2 blocks across to go from the y-intercept to the axis of symmetry, and so I'll go 2 blocks further to the right, and that will find me the point of symmetry. That point, of course, is 4, 5, and I now have 5 points on my parabola, and I can go ahead and draw a sketch of my parabola. And so again, do not use a ruler. Make sure that you are just drawing as well as possible a nice smooth curve that passes through the points. Not the best one I've ever drawn. Arrows on the end to indicate that it continues forever, and that should be, or hopefully is, what your graph looks like. We've labeled our vertex, our axis of symmetry, our y-intercept, the symmetrical point, and our 2 x-intercepts, and we've completed it by putting arrows on the front or on the branches to indicate that it continues forever downwards. Okay, and so make sure you have the correct answers for the 2 examples copied down, and now what you need to do is turn your attention to the assignment.